Hey, welcome. I'm going to do a little bit of recording on decimals, percents, and interest for math for elementary school teachers. Share my desktop here. So, I'm going to start with percentages. The word percent has a very literal meaning. Per meaning divide by, like miles per hour, and cent meaning 100. And you can see that in the symbols. So if we take one we're very familiar with, like 50%, you can see the divide by symbol and the two zeros for the 100 living in the percent symbol. So it's a shorthand for dividing by 100. So 50% literally means 50 divided by 100. That was also looks like the division symbol. We have two choices from here. We could write it as a fraction and reduce. We get maybe 5 over 10 first, and reduce one more time and get 1/2. Or we could actually carry out the division and take 100 into 50. Reminder about our division here. 100 doesn't go into 50. Placing the decimal, and we can do this as long as this divisor is a whole number. And we can ignore the decimal for a minute and say 100 goes to 500 5 times. 5 times 100 is 500 in the remainder. So if we carry out the division by hand on the calculator, we get the decimal version. So changing from a percent to a regular number is pretty easy. You just state what the percent symbol means and then reduce or divide. If you want to go the other way, then you just consider the fact that 100% is equal to 1, right? 100 over 100. So if somebody gives me a number like, say, 3/10, 3/10 is the same as 3/10 times 1. And 1 is the same as 100%. And so then I just clean up the multiplication, leaving the percent symbol hanging out. So if I take 3/10 of 100, I get 30, the percent symbol hangs out. So it's pretty easy to convert a percent to a regular number or a regular number to a percent. Now, we don't want to get confused with when a number is percent and when it's a regular number. We need percents written as regular numbers to do calculations. Percents are useful when we're communicating with people. So one example of caution would be if I have this particular number. Now that's 1/2%, 0.5%, right? So I can write it this way too. This is not equal to 0.5, and 0.5 is 50%. This is 1/2%, it's less than 1%. And the percent symbol is still there. So in order to write this number, I have to take either form, the fraction or the decimal version, divided by 100. Let's do the decimal since I started with that. And we might remember the trick that dividing by 100 shifts the decimal 2 places to the left. And so this would be 0.005. This spot right here is a whole percent, 10%. That's 1/10 of a percent. So I have 5/10 of a percent here. So we do have to be cautious. Percents and decimals do mix. We can turn a percent to a regular number, and that regular number could be a decimal or a percent. Once we do that conversion, the percent symbol goes away, right? Because percent literally means divide by 100. All right, next. Percent basics. We're going to play with a little interest. You might remember playing with simple interest once upon a time. So with simple interest, the interest amount is equal to whatever your balance is. Sometimes that's called the principal. Times whatever the rate is, times whatever time has expired. It's often abbreviated. I equals P R T. Again, principal is another word for your balance. Often, rates are given as annual percentage rates. Meaning the rate applies to the whole year. So if somebody gave me a rate, an APR of 12%, then the monthly rate would be 12% split into 12 months, or 1% per month. So if I had a $100 balance, and I'm going to use the 1% monthly rate, call that an NPR, monthly percentage rate. And for time, 1 month went by, then my interest would just be 100 times 1% as a decimal times 1. So 1% 100 is $1. All right, so that's simple interest. And we can play with simple interest in a variety of ways. So let's just do that a little bit. So let's suppose somebody had 20% increase on $20. So one question we could ask is, what is the amount of the increase? And we want to be careful to distinguish between a percent increase and an amount of increase. So here, I could just take my 20% and multiply it by my $120. And with my calculator, do some arithmetic, we should find that that is $24. Good. So that's the amount of increase. So if I were to take the increase and add it to the original, I could say there's a total of 120, the original, plus $24, altogether giving me 144 as a new amount. Now keep in mind here, that 24% there represents 20% increase. I added 20% to what? To the original. The original amount is always 100%. So you could say that this 144 is 120% of the 120. Of means multiplying that, changing that percent to a decimal, I get 1.2 times 120. And if you do the arithmetic there, you should find that's $144. So sometimes it makes sense when you're working a percent problem to work out of 100% instead of doing the problem in stages. Sometimes you have no choice. That's just the way it works. So let's try another one. How about, say, after a 20% increase, Gary has the number $84. What was the original amount? Ooh, sorry, I hit a weird button there. Go. So let's see. Common way to attack this problem would be to try and take 20% of the 84 and then subtract that. But that is bad math. Why is that bad math? Well, think about it this way. I have some original amount. I'm not really sure what it is. and somebody took 20% of that. And then they added that back onto the original amount. And that's where the 84 came from. So it's not the 84 that ever got multiplied by 20%, it's that original amount. So this is just an incorrect use of percentage right there, so we can't do that. But what we can note is that this part right here that makes up the 84 is what we call the 20%. And the original amount here is always 100%. So the 84 must be 120% of something. And so then I can just solve this for the 84. So 84 must be, or sorry, the original number must be 84 divided by 120%. And to use 120% in calculation, I have to call it 1.2. And then if we do that, what we should find is that the original amount was $70. Double checking that. If I take 20% of 70, I'll get 14 plus 70 gives me 84. Slightly different way of doing that besides this kind of algebraic routine. I'll show you a couple other ways. I could use percent as a proportion, in which case you would have percent over 100. And by percent, I mean the number without the symbol, not the converted value. So 50 as opposed to 0.5, 50%. And then here we have some new value over some original value. Just a matter of putting things in the right spot. And so my new value for that problem was the $84. And I didn't know the original. We call that box. We call it X if you like. X is overrated. On the other side, I have 100%. And the big problem is what to put up there. Well, the 84 isn't 20% of something. It's 120% of something. So sometimes we have to think out of 100%. So we have to use that kind of reasoning. So I put the 120 there. And then if I cross multiply and divide, I should find the missing number is 70. It's a slightly different way to set it up. One more way would be to use a picture. So what I do is I draw a long bar. And on that bar, I make a note that this right here would be 0%, and this right here is 100%. And then I have to decide, where does the 20% go? Well, the original problem said Gary had a 20% increase. Oops, here. After a 20% increase, Gary ended up with 84. So I have to increase this by 20%. So I need to do my best 20% here. If you think about 20% being 1/5, you can imagine, let's see, I think about here would be 1/5, 2/5, 3/5, 4/5. So 20, another 1/5 would be right there. So thinking about this as a ruler is a really good idea. So that right there would be 120%. And then right here, I have the $84. And what I want to know is what dollar amount goes here. Now, this won't work for any problem easily. Sometimes it can make it a nastier problem. But here, since the extra 20% works well with 100, because 100 can be broken into a bunch of 20%s, right? Each of these boxes here represents 20%. Well, how many boxes do I have? Well, I have 1, 2, 3, 4, 5, 6 boxes. Well, the 84 then could be broken up into 6 pieces. So if I take 6 into 84, what do I get? Let's see. 6 goes into 8 once, with 2 left over, and 6 goes into 24 4 times. So each of these boxes is worth 20%, or I could say each of these boxes is also worth $14. And how many of them do I have? Well, to get to the missing number there, I need 5 of them. So if we check what is 5 groups of 14, we would find it is 70. Each of these boxes is 20% because 20 and 100 work well. Similarly, the 84 can be broken up into 6 pieces according to my picture. Despite my artistic troubles, those are supposed to be equal pieces because each of them is supposed to be worth $40 each. Be cute, huh? All right, one more thing. Last thing we're going to do is look at compound interest. And really all compound interest is repeated simple interest. So let's say what we're going to do here is we're going to watch. Oops, I can't spell watch today. We're going to watch $100 grow. And we're going to watch it grow monthly with an APR, say APR of 12%. So we should make a note here that the monthly rate is going to be 1%. Now, similarly, if we just think of the basic computation for interest, EI equals PERT, if the rate is measured in years, time has to be measured in years. The calculation for 1 month would look like this: $100 times a rate of 12% times 1 month, which is a 12th of a year. And here we can see that 12% divided by 12 hiding in that formula right there. That's 1%. All right, so I'm going to need to keep track of the month that I'm in. And let's see, we should keep track of the interest. And we should keep track of the balance. And we're just going to watch. So I just like to put a 0 month in here. There's no interest, and I have $100 sitting there. Then a month goes by, and I get to calculate 1% of $100. And so I get $1. So my new balance is then 101. And another month goes by, and I get to calculate 1% of my previous balance, which is 101. And see, that's going to be $1.01. And so when I have it on here, I'm going to get 102.01. And we're going to need a calculator soon. So let's see, we have Google to use as a calculator. Third month goes by, and I'm going to take 1% of my previous balance, which is 102.01. And now we need a calculator. And we're going to remember to add that back onto the balance. So Google calculator. So Google, what is 1/100th times 102.01? Google says it is 1.0201, and I want to add that on to my previous $102.01. And Google says that's going to be $103.03, and then we're going to have a 100th of a cent along with that. So that notebook, 103.0301. Now this is getting a little bit tedious. We're doing the same thing each time, right? So let's just take a look at what happened, broke it out in a different way. I added 1% of my 100. Well, 1% plus the original number, that's 100%. Really what I'm adding there is 101% altogether. So I have 101% of my previous balance, $100. And that's where the 1.01 comes from. And the bottom line is each month, I'm going to get 100, I'm going to end up with 101% of what I had before. So if we just double check the next line, this right here should be equal to 1.01, 101% of the previous balance. The previous balance was 101. So if we go back to our Google calculator, clear that, take 1.01 times 101, out should pop our 1201. And if we multiply that by 1.01, we get our 103.0301. And we're just going to, so basically every month, we're just repeatedly multiplying by 1.01. So if you think about it, this third number here, if I trace it all the way back to its origin, was a $100 amount. And then for the first month, it got multiplied by 1.01. For the second month, it got multiplied by 1.01. To get from here to here, I multiply by 1.01. To get from here to here, I multiply by 1.01. And I have to do that one more time. And remember, repeated multiplication is an exponent. So I believe that that $103.03, 3 cents, 100th of a cent, is really $100 times 1.01 to the third power. So I'm going to ask Google calculator what it thinks about that. So here, $100 times, I think I hit this button next. Oops, here, times 100. Excuse me. 1.1, there we go, raised to the power 3. Enter, I get the exact same number. So now I have a shortcut. Instead of having to calculate this month by month, I have a formula. And that's the compound interest formula. So if somebody said, well, can you give me what happens after a year? Okay, well, that would be 12 months. I'm going to skip the monthly calculation of interest and jump right to the fact that I believe then that it would be $100 starting times 101% repeated 12 times as a multiple. So I'll ask Google about that. That is so clear. $100 times 1.01 raised to the 12th power. And we will make $112.62 and then 1/4 cent, which the bank will probably keep. So this is approximately wavy equals sign $112.68. So compounding monthly, I'm 68 cents better off than I would be if I just received 12% at the end of the year. That would be just $12 extra. So summarizing this formula, the version I have here takes the principal and then multiplies by parentheses 100% of the principal plus your periodic rate. I'm going to call that I. Raised to the power n, number of periods. So like before, P is our principal. I is the periodic rate. In this case, the monthly rate. And M is the total number of periods, the number of months in this case. There's another variation on this formula that you'll see a lot, where it'll look like a principal. And again, this is usually represents a future value, F, times 1 plus, and often they'll let R represent the APR, in which case, if we have compounding periods, N would be the number of compounding periods per year. And then the power would be the number of periods per year times the number of years. So these are basically the same formula, slightly different ways of looking at it. So these slightly different variables. R here would be an APR. N here is the periods in a year. Monthly would be 12, yearly would be 365, and T is the number of years that have elapsed. And both formulas, if you plug in the right numbers, yield the same results. That's compound interest, just repeated simple interest. formula's not too bad. Good luck playing with this. Hopefully I'll see you all sometime in the future. Have a good day.